Thank you for the request to explain the integral of sine 2t cos t. Let's have a go at it. It's not an easy integration to do. Maybe your first instinct is that you need to get rid of the 2t component part of the sine 2t, so that both these trig identities have just a single variable t in them. And if that is your first instinct, then you're right. And even better if you thought I could get rid of that by saying, well, I know that sine 2a is 2 sine a cos a, so instead of writing sine 2t, I could write 2 sine t cos t. So if we did that and wrote 2 sine t cos t instead of sine 2t, then we're going to have cos t times by cos t here, so we're going to get a cos squared t. So we're trying to integrate 2 sine t cos squared t as a result, and that's equivalent to our sine 2t cos t. What comes next is a bit more tricky. There's no obvious route to go down now. But what I would say is just consider using the reverse chain rule. And how would that work? Well, reverse chain rule, you kind of have to think backwards and thinking, what would I differentiate to give me something like this? So in other words, you need to have had plenty of practice on differentiation and to sort of recognize patterns. So maybe you want to just pause and just have a look at this for a few seconds and think, what might I think differentiate to give me something like this, with the clue that you're going to be using the reverse chain rule. And well done if you perhaps on a hunch you thought, well, maybe it's something to do with cos cubed t, because I've got a cos squared t. Perhaps if cos cubed was differentiated, I'd get something with cos squared left in it, and you would. Let's have a look at how. So if I consider differentiating cos cubed t, and I chose to use the chain rule, so I said let u equal cos t, and as a result I was trying to differentiate this. Well, using the chain rule I could differentiate u cubed, with u replacing my cos t here, and get 3u squareds. And I'd also have to think, what would u differentiate to become? Well, that would give me my negative sine t. So putting these together using my chain rule, the differential of cos cubed t would be my du by dt times my d by du rather times by my du by dt. In other words, I'd get 3 cos squared t times negative sine t, and I'd have negative 3 sine t cos squared t. Okay, so this looks really similar, doesn't it? The only difference between this answer here and the problem we've got is that, and this problem here is that this is negative 3 sine t cos squared t, and this is 2 sine t cos squared t. So all we need to do now is just think carefully about the constants that go in front of these. Let's just check you've followed the video so far. What would I integrate if I integrated negative 3 sine t cos squared t with respect to t? What would I get? So I integrated negative 3 sine t cos squared t. What would I get? Pause it, just give yourself a few extra seconds. And well done if you said, well, if I integrated negative 3 sine t cos squared t, I would get cos cubed t. That's what we've just differentiated cos cubed t to get negative 3 sine t cos squared t. So if I integrated negative 3 sine t cos squared t with respect to t, I'd get my cos cubed t plus some constant of integration, being formal about it. Right, so that means if I was going to integrate sine t cos squared t, what would I get? Well, it's going to be, this is the only difference between this problem and this problem is that had negative 3 in front of it. So I must get the same answer, but divided by negative 3, so I'd get negative a third cos cubed t, wouldn't I, if I integrated that? It's just going to be this divided by negative 3. So if I was trying to integrate two of these, 2 sine t cos squared t, well, I'm going to get 2 lots of what this was. So I'm going to get negative 2 thirds cos cubed t plus some constant of integration. And that's how you integrate sine 2t cos t. Hope that helps.